Okay, so functions are what? It's a relation pairs input with outputs, correct? When a relation is given as an order pair, the x coordinates are inputs and the y coordinates are what? Outputs. A relation that pairs each input with exactly one output is a function. Meaning, if I have, let's say, x and y in my order paired, right? How do I know it's an order paired? Because it's in a parentheses, okay? That's how I know it's an ordered pair. It is in a parentheses. And when you think of ordered pairs, you think of what? Graphing, okay? You think of graphing. Remember your grid? There you go, what? X goes what? Up or down, and y goes what? Left or right? Do you remember that? Okay, so what would x be? X will be my, based on the definition, what would x be? My x coordinates. Are those my inputs or are those my outputs? The what? Input, right? That means is what you what? Input into the equation. And what will be my output? My output would be y. So say, for example, I have y equals x plus 3, correct? Let's say y, this is an example, y equals x plus 3. And then I tell you that my x are 0, 1, and 2. I need to find my output. So what does that mean? I'm going to write what? I'm going to input what? It's substitution. I'm going to use substitution to what? I'm going to use substitution where my x is at. Correct? So what will my y be? What's 0 plus 3? 3. So that means that my output is what? 3. If I use 1, what will my output be? 4. And if I use the 2, my output will be 5. So if we look here at this table right over here, my x's are climbing by what? By 1s, right? And my y's are climbing by what? By 1s as well, right? But there's a difference between each of them as what? There's a difference of 3, right? So you always have to think of your tables and functions also as patterns, okay? As patterns. But sometimes it might not be a function. So when would that be a function?
There's no pattern.
Huh?
There's no pattern.
When there's no pattern. And also when each input is exactly with one output. What does that mean? We're going to go through that, okay? Let's go to the next slide. So let's determine which one is here, which is the relationships, which is to a function. I want to know which is my output here. Which are my outputs here?
The one on the right.
Huh?
The one on the right.
The one on the right? Who can tell me what are my inputs here? To the left, right? So -2, -1, 0, 1, and 2 are my what? Input, right? And my output is what? 2, 2, 2, 0, and 0. Who doesn't see that? Which are my outputs, guys? Are what? My x's, no? Which in this case are -2, -1, 0, 1, and 2. My outputs are my what? My y's, right? In this case are what? 2, 2, 2, 0, and 0. Is this a function? Is it a function? So the way you're going to determine is a function is if our outputs are what? Not repeated. Okay, not repeated. Are there any inputs that are repeated? No, right? The outputs are, I put out, my outputs are what? Repeated. But is any number in my input repeated? So this is going to be a what? This is going to be a function. It is a function. That means that I'm going to have, my line is going to go where it's going to work. Okay, it is going to be a what? Function. Every output has exactly what? One output, okay? Every input has exactly what? One output. Let's look at this side. Now I have here what are my inputs here? 4, 8, 6, 4, and my outputs are what? 0, 7, 4, 3, and 2. Do I have any repeats in my input? So that means that this is going to be not a function. Why? Which one is the one that's being repeated? 4 has 2, right? 4 has 2 functions. Two inputs. So it's going to be not a function.
So,
Yes, Miller.
so to determine if it's a function, we're going to look at the inputs.
Inputs, yeah. And they cannot be repeated.
So it doesn't matter if
Your outputs.
inputs have, no?
No. Your inputs are the ones that cannot be what? Repeated. Let's look at the next slide. We have what? We have him now in a table, correct? They're actually already separated from us, right? They've separated the order pairs for us. Let's look at our inputs. Is it anything in our inputs repeated?
Yes.
Which one?
0.
0 is repeated, correct? So is it a function? It is not a function because it is what? Repeated. Repeated. I'm showing you in different ways that you're able to see the order pairs, okay? You could see them in order pairs with parentheses. You could see it in a table. And I'm going to show you now in a graph, okay? Now here we have what? We have our inputs that are X and our outputs that are Y. Do we have any repeated here?
No.
Huh?
No.
So it is a what?
Function.
No repeat. It is a function. The -1 here is -1 and what? 4, 3 and 15, and 11 and 15. Even though we have what? Sometimes it will throw you off because you see this here are repeated, right? Well, not the 4, obviously, but sorry. The 15s are repeated, correct? But that's in my output. So my outputs can be what? Repeated, but not my what? My inputs, okay? Let's go on to now what we call vertical line test. So what does each of these, if we look at these, what does each of these dots represent? They're an order pair, right? They're an order pair. So why do you think a graph represents a function with no vertical lines passes through more than one point on the graph? What does that mean? Yes, Miller.
That means that it doesn't matter how funky the shape is, if it passes through one time, it's a function, but if it passes through twice, it's not a function.
It's not a function, correct. So if we notice here, no matter how many times on the first one's a function, why? Because even if I do it, let me do a small, thinner line. Okay, even if I do a line here, am I touching any other points there. If I do the one here, either here no, and here no, right? So that's why it becomes a function. There's no 2 points touching. But now let's look at where it says not a function. Do you see this here? And here? It touches, right? But let's say I do a line here. Is it still touching 2 points? Correct? It's touching where? We're touching here and here. That means that it is not a function. Got it? Now we have, let's determine whether each graph represents a function. Does A represent a function? Is it a function or not a function? Not a function. Because what is touching? We have what touching? The 2 and what else? And the 5, right? The 2s and the 5s, when you look at it, they're going to be touching, so they're not going to be a function. What about B? It's a what? A function, because nothing, if you look at all my lines, it does not touch, correct? The line does not touch any other point in the graph. Okay, so we've seen them in what? In graphs. We could see them in tables, in order pairs. So in the end, always remember, which one is this one? This is your X and this is your Y. Can Y be repeated? Can Y be repeated? Can X be repeated? No. Okay, let's go on to the next slide. Now when we have what we call domain and range of a function. So what does that mean? The domain of a function is a set of all possible input values. So your X's are going to be your what? Domain, which is the same as what? Your inputs. And your Y's are going to be your what? Range, which is the same as your outputs, okay? So remember, the domain of a function is a set of all possible input values, all possibles. But your ranges are what? Our function is a set of all possible output. So think about the example I gave you first, right? We had what? It was Y equals what? X plus 3, we said, right? That was an example we used, right? And I said 0, 1, and 2. And we had what? 3, 4, and 5, correct? So my X's here are what? My range, and no, not my range. My domain. And my Y's are my what? Range, correct? So if you recall, domain are always going to be your X, which are your what? Inputs. And your Y's are going to be your range, which is your what? Output. There's a difference though, for it to be a function, okay? Your domain, sometimes you're going to write down your domains and see. Your domains are basically your X. But for it to be a function, can X be repeated? For it not to be, correct? It cannot be repeated. Okay, let's go to the, I'm going to work on some of these. Let's find the domain and range of the function represented by the graph. Let's look at A. Let's look at A. What are my domain in A? Who can tell me what are my A and what are my domains in A in the graph? No.
You mean the points?
Mm-hmm. We have what? Remember, your X's are what? Your X's are your what? your domains, right? So which are the domain here? So let's see. We have what? -3, you said. Good. What else? -1, 1 and 3. Are there any repeats there? So if you could see here, there's a line going up, right? There's a line going up. What are my range here? What are my range? We have -2, 0, 2, and 4. Does everybody see that? So if in reality, the first one is the order pair -3, -2, right? So I'm going to go over what? I'm going to go left 3 and go down how many? -2. And that's where my point is. Now let's find the domain for graph B. I only have 2 points there, right? What is the domain? What is it? Definitely 3 is 1, right? What is the other one? -2. And what is my range? Which is my range here? What is the output of -2?
-1
-1?
and 2.
-1 and what?
2.
And 2. That's my range. Is it a function? Is it a function? Why is it a function? There's no repeat, right? All right, let's go on to the next slide. Let's do these examples together. Number 1, we need to determine what? We need to determine if it's a function or not a function, okay? Okay, number 1. Is number 1 a function? So what I would always do is do this. Underline your y's. So you could just do what? I mean, not your y's, I'm sorry, your x. Just so you can see your inputs. What's repeated there? 5. So it's not going to be a function. And number 2, let's underline our outputs. Are any of my output, not output, I'm sorry, confusing them. Are any of my inputs repeated? So it's going to be a function. What about number 3? Number 3 is what? A function. None of my inputs are repeated, right? So it's going to be a function. What about number 4? Not a function. Why?
Because half is going to all of them.
The half is going to all of them, correct. Half is going to all of them. So it's not going to be a function.
Playing ping pong baseball.
Okay, now we're going to determine whether the graph represents a function, okay? And we're going to explain. Number 5, is that a function? Why not? Is it a function? It is a function. Why? The input is different. My y's my outputs are the same, right? So all my what? If you look at here, number 5, they're all what? 0, 1, 2, 3, 4, and 5, right? Those are my input. But my outputs are what? They're all 3. Got it? They're all 3. So it is a function because my inputs are not repeated. What about number 6? It's a what? It's a function. Why? It doesn't touch, even though it looks like a U, right? Even though it looks like a U. Now, if it was going this way, but we're not going that way. That's why it's important to understand that it's going to be what? Vertical. The line's going to be vertical, okay? Not horizontal. Your line vertical means what? Up and down. Horizontal means what? Sideways, right? Always remember that. What about number 7? Not a function, right? Why is not a function? I can see what's repeated there. There's a couple that are repeated, right? Here, the 3s. Correct? My 3 there is repeated. What about number 8? Nothing is repeated, correct? All right, let's go on to next. Find the domain and range of the function representing of the graph. So they're already telling me that it's a function, correct? All we're looking for is a what? All we're looking for is the domain. So let's look at number 9. We're looking for the domain and the range. What are the domain here? -2, -1, 0, 1, and 2. It's always important to do them in order, okay? Because if you have to pair them up in ordered pairs, if you have different numbers, what's going to happen? Your point is not going to be the same as what's graphed. Okay, what is my range here? So, 0, 2, and what? Another 2 and 4. 4. Do I need to repeat my ranges? No. Okay, I don't need to repeat the ranges because I already know that I'm going to have, by knowing that I have only 3 numbers at the bottom of my range, they're going to repeat it. So my -2 goes with what? What does my -2 goes with? With what? With 4, no? No? And my -1 goes with the? With the 2. And my 0 goes with the 0. And my 1 goes with the? With my what? 2. And then finally my 2 goes with my 4. So you're going to have repeated. Correct? All right, what about number 10?
Why would -2 go with 4?
Because you go over -2 and then you go up 4, no? So that's going to be what? -2 and 4. So y is my output is y, which is 4, and my x is -2. Okay, what is my domain for number 10? It's going to be what? 1 and 5. And my range is going to be? 4 and what? 4. Now, can I rewrite this? Right here. What have we been doing? We already learned inequalities, right? Did we learn inequalities? What is my first one? My domain is what? 1, correct? That first point is 1, right? So 1 is going to be what? Less than or equal to what? To x and less than or equal to 5. And what about my range? My range starts at what? Did it hit the bottom? Did it hit x? Does it hit the x?
Yeah.
And the x is going to be what? The bottom. 0, no? It went over, correct? But it's going to hit 0. So 0 is going to be less than or equal to what? Y. And it's less than or equal to 4. Can I put where my 0 is 4? My ranges are both 4. But it does hit at the bottom, doesn't it? So that means that my domain is going to be 1 less than or equal to x and less than or equal to 5. And then finally, my range is going to be 0 because it starts at 0. Do you see where the line right here hits the bottom? Okay, we're going to work on that a few more, okay? Because I know that one's a little bit confusing, but we're going to work on that one. But I just want to introduce this, but I will work on how we figure that one, the inequality, okay? We already are familiar with inequalities and compound inequalities. These are going to be my and. Remember, and means that they're intersecting, right? And means they're intersecting, but we're going to work on that. Let's go on to the next slide. My next slide is identifying independent and dependent variables. What does that mean? The variable that represents the input values of a function is going to be called your independent, okay? The variable that represents is the independent because it can be any value in the domain. What do we say the domain means? My domain is my x, right? Now the variable that represents the output values of a function is what? Dependent variable because it depends on the value of an independent variable. So now, what is going to be that? That's going to be my y, which is my range, right? When an equation represents a function, the dependent variable is defined in terms of the independent. The statement y is a function of x means that y varies depending on the value of x. I know. Ms. Gonzalez is like, what did you just say? Okay. Basically, it means my input, whatever I put an input, is going to be what? It's independent. Who's dependent of my, who depends Y depends on who? Y depends on X, Y.
It's a dependent variable.
Yes, because anything, you could write anything for your input, right? Remember the box that we had here? This is X and Y, correct? So I could have 0, 1, 2, whatever numbers I write. I could write anything there, and what does that mean? Does Y depend on whatever X?
Yes.
Do you normally look for Y and then X? No, right? So who is going to be dependent on it, on my output? So look at here on the graph I wrote there. I put Y equals what? Negative X, correct? Which is my dependent variable there, the Y or the X? That's what we call dependent, okay? And my x is my independent. In other words, it doesn't matter what I use for x, okay? Whatever number I'm going to plug in for x is going to be independent. But my y is going to depend on what I write on that x, on what number, on what I use. Because if not, it might not be a function. Because why? If x is repeated, I'm not going to have a function, correct? So did y matters? Does y matter when it's repeated? No, right? It's not going to matter. Only way is if it's going to be a function. Okay, let's go to the left here and let's think. Number 11. Okay, we're just going to work on these. The function a equals negative b plus 14 represents a number of avocados you have left after making b batches of guacamole. A, identify the independent and the dependent variable. Which is my independent here? What is it? B is my independent. And what is my dependent? You know what? Let me write it out completely so you guys can see it. So my independent is what? B, right? And what's my dependent? A is my dependent. Okay, A is my dependent. Now, and B, the domain is 0, 1, 2, 3, 0, 1, 2, and 3. What is the range? What does that mean? You're going to have A here, negative 4B plus 14. What am I going to use with my domain? What are my domains? My domains are my x, correct? So I'm going to, but in this case, what is really my domain? What is the representation here? B, right? B is the representation. So I'm going to plug in for every domain number that they gave me, I'm going to plug in for B. So I have A equals, what is the first one? Negative 4. What's B here? 0 plus 14. What is A here? What is A? What's negative 4 times 0? What is it?
0.
So that means that my first is going to be 14. My first range is going to be 14. We're doing substitution. My second one, we already established 0. What's the next one? 1, right? So it's going to be A negative 4 times 1 plus 14. What is going to be A for when it's the domain is 1? Huh? What's negative 4 times 1? And negative 4 plus 14 gives me? What is it? 10. So my second range is going to be 10. What happens when I plug in 2? I'm going to have A equals negative 4 times 2 plus 14. What's negative 4 times 2? And what's negative 8 plus 14? Positive what? So that means my third range is 6. What happens when I use 3? A equals negative 4 times 3. So what's negative 4 times 3? Negative what? Negative 12. And what's negative 12 plus 14? Positive 2. So there are my ranges. Did we see how I found my ranges? All I did was what? Substitution. Wherever first, that's why you need to identify which is dependent and which is what? Dependent. So normally my independents are my y and my dependents are my what? X. My domains are my x. My range are what? Y's. So it's kind of like just the same thing over, just with different what? Vocabulary. Let's look at number 12. The function T equals 19m plus 65 represent the temperature T, which is degrees in Fahrenheit, of an oven after preheating for minutes. Which is the independent here?
The M,
Which one?
M,
Independent is going to be M. And what's going to be my dependent? What is it? T is my independent. Now, what's going to be my range here? I wasn't giving no range, right? And I wasn't giving no domain, correct? But I was given what? I was given a equation, and I was given a. Now it tells me a recipe calls for an oven temperature of 350 degree Fahrenheit. Describe the domain and the range. What will be my let's look at the domain first, because normally domain. What do you start at? Domain, you normally start where? Don't you normally start at 0? Is your oven already preheated? You're going to start at 0. So that means that it needs to start at 0, right? Your independent is going to start at 0. That means that, and it's going to have to be what? Less than or equal to who? To M, right? M is your minutes, correct? Less than or equal to what? 15. Okay. How do I get 15? How do I get 15? A recipe calls for an oven temperature of 350 degrees. Describe the domain and the range of the function. If I have, I did what? Multiply? Or did I divide? I what? What did I divide by?
19.
I divided what by 19? Would the temperature give me that? What do you guys think I got that? Let's first find a range and I'll explain it to you guys, okay? Look at our range now. What is the minimum? 65. It was given to us where? In our function. 65 is less than or equal to temperature of what? Less than or equal to 350. All right. I'm going to erase this on the side to explain. To explain what we got there, okay? So remember, our range is what? Our range is our independent, right? No, our range is our dependent. And our domain is our what? Independent. Our range is always going to depend of whatever I input, right? That is my domain. That's what I start off. When you start the oven, where do you start your oven at? 0, right? So if you look here, I have what? T equals 19m plus 65. What is T? T is my temperature and M is my what? Minutes, right? T is my temperature. What temperature do they tell me they're going to have? 350. Didn't they tell me they're going to have 350? Correct? I'm going to have 19m plus 65. What do I do here? Who am I getting rid of here? the 65 by what? By subtracting on both sides, and I'm left with what? 19M. What's 3650 minus 65? Huh? 280 what? 285. And now what am I going to do? I'm going to divide by what? By 19. And what do I get? Do I get 15? Yes. So that means that when the recipe calls for an oven temperature of 350 degrees Fahrenheit, okay, it's going to take me how many? 15 minutes. Normally you start where? At 0, right? Is your oven is your oven hot when you go into your kitchen? Well, it's always at 0. And then it's going to start climbing up, correct? So in this case, how many minutes it's going to take for it to be at 350? It's going to take 15 minutes to get to 350 degrees. Got it? The temperature. Now my range, which is my dependent, right? What am I doing there? I have what? 65 was given. 65 was given, right? That was given. It says it takes what? The function T equals 19M plus 65 represent the temperature in degrees of an oven after preheating. So that's how much degrees is going to be preheated. So M could be what? 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes. Whatever you plug in there, you're going to have for temperature. Got it?